Hi, my name is Long Xianli, and Chenji and I work together to finish this final project named Cities Counts Image Classification Challenges. First, I'm going to introduce this project. This project is about citycounts.com. This is an e-commerce company that uses machine learning algorithm to classify many products, and in this challenge, we will build a model to train these data and try to classify these products and basing on their images. Our goal is to use try to find which image belongs to which categories and try to predict the category IDs. So the first I'm going to introduce the kernel and the models we use. Our code is based on convolution neural network and contains the application for carriers called VGG16, and at the same time we use Python iterator to read directly from the Python data. And for this model, we use CNN module. There are total 8 layers, and 2D convolution layer, max pooling layer, 2D convolution layer, max pooling layer, and 2D convolution layer, and max pooling layer. And to train, we use this model to train this data. And the first step, we add libraries into Python and download the data and read the data. Actually, the train data is about 58 gigabytes, and the test data is nearly 15 gigabytes. It's so huge, and we cannot train it totally, so we just train some of them. In train data, main there are three main variables: product ID, num image, offset line, and category ID. And and in test data, it's the same format as train Python, but there's no category ID. So our goal is to try to find the true category ID of every image. And the next step is we randomly split on the products of train data, and we use the ratio of train and to validation size 4:1, and then we use our models to train these data. Um, and the next step, the test, we're using VGG16 to pre-process the test data, and then use actual its extracted features to test the data and try to find its accuracy and error metrics. In error in about the performance and the evaluation of it, we're basing on the confusion matrix. The reason we use it because the confusion matrix can directly show the performance of its. And the row is actual product ID, and the column is predict product ID, and the size is over 5,000 by 5,000. And in this way, we can figure out which specific classification are wrong, because we know the numbers. And we think the problems of our module is the first is the data is huge, so we cannot train the whole data. We just train the example data, and thus the accuracy of our model is sort of low. And the weakness of this model, another weakness of this model is the calculation rate. As we know, the neural convolution network is, when we use that model, is pretty slow because we train from and to front, and sometimes. So the calculation rate is pretty low, and we need to wait for a long time. And sometimes we train this model using nearly 20 hours. Yeah, and I think there are some solutions to solve this. The first is we can predict a mini batch per product, and the second is we can use solid state disk to store this data, which could be much quick. And the third solution is we can use multiple CPU threads to create several batch in parallel, which means we can train it together and use the CPU. And I think we think the another problem is our module is simple, and we think we can use ResNet 101 model to train next time. So that's what we did before, and we are gonna use a new model to train this. Uh, yeah. So that's our presentation. Thank you.